Hello. In this presentation, we will look into the boundary scan instructions. After watching it, you should be able to list all the mandatory and some of the optional boundary scan instructions, and also to explain how each of the mandatory instructions affect the operation of the test logic. And finally, you will also be able to explain what happens when a new instruction is loaded and how this operation can be used to test the integrity of the boundary scan chain. So the four mandatory instructions are described in this slide. The external test is the one that is most commonly used. An external test selects the boundary scan register in between test data input and test data output pins, but the boundary scan cells are in isolation or controllability mode. That is to say, the pins are isolated from the core circuitry. So the main feature of the external test instruction is that the boundary scan cells isolate the core circuitry from the pins. Now, the two following instructions, sample and preload, they also select the boundary scan register. So it will be this register that is connected between TDI and TDO. But in this case, the boundary scan cells will be in transparent mode. That is to say, all the pins will be connected to the core circuitry. Well, sample is used to enable us to capture the values that are present at the inputs of the cells and to shift them out for observation. And preload is used to, well, as the name indicates, to preload the logic values of the first test vector to be applied to the board. Well, finally, there is a bypass mandatory instruction which, as the name suggests, selects the bypass register, that is to say the 1-bit register between TDI and TDO, which offers a shortcut through those devices which we do not wish to access. Notice that when the bypass register is selected, the boundary scan cells will all operate in transparent mode. This is actually the operating mode that is defined by default when you power up the board. So when you switch on the power supply, all the devices will operate in this mode. The bypass instruction will be automatically loaded into the instruction register. The bypass register will consequently be selected between TDI and TDO, and all the boundary scan cells will be in transparent mode. There's a number of optional instructions like internal test, run built-in self-test, ID code, there's a demissing clamp, high C, and so on, but you can check the standard, the IEEE standard itself, to see what they mean. Now, before concluding, I would still like to tell you three things that are important about the instruction register. One of them is that each bit in the instruction register actually comprises two stages in a setup that is actually similar to what you saw in the boundary scan register cells. So while we shift in a new instruction, actually the decoder will still see the previous instruction, and it will only be when we update the outputs of the instruction register after having completed to shift in the new instruction. Only after that moment will the decoder see the new instruction. So the fact that there will be bits passing through the instruction register doesn't cause any problem until the new instruction is updated. Another important issue is that instruction registers will frequently have like 8 bits, but we may have only like 20 instructions, so there will be a large number of unused operation codes. Well, normally all those operation codes will simply select the bypass register, so by default an illegal instruction will select the bypass register. It will work as if it was the bypass instruction. And last but not least, an important feature is that when we shift something into the instruction register, what comes out at TDO is always the same fixed pattern, which comprises 0, 1 in the 2 rightmost bits. That is to say, whenever we shift in a new instruction, what comes out at TDO will always be the same logic pattern. And in this logic pattern, the 2 last bits are 0, 1. And why is this important? Well, it is because in this way, we'll always drive a 1 to TDO and then a 0 to TDO. And this 1 and this 0 will toggle the logic value in every TDO-TDI interconnections in the board. And we should see them coming out at the board TDO while we shift in an instruction. And the importance of this feature is that if there is a broken interconnection between TDO and TDI, for example, then we will be able to find out that the boundary scan infrastructure itself is not operating properly. And that is because we are sure that we expect to see a 1 and a 0 coming from every device in the board whenever we shift in an instruction. So this 0-1 pattern that comes out from every instruction register is a very important design decision of the boundary scan infrastructure that enables us to check the integrity of the boundary scan infrastructure before we actually start to use it for testing the boards. Thanks for your attention.